In this problem, we're given a formula for a function h of x. We're shown a table for a function f of x. And we're also given a graph for the function g of x. And our problem is to find the composition of the inverses. Remember, the reason for this channel is to give you tips and help you pass your math class so you can reach your goals and get a better life. Composition of inverse functions coming right up. I want to think about the table first because we're almost comfortable with the formula. And I want to remind you that the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. So let's consider this function f. We've got a table, and we can actually generate some ordered pairs from the function. When x is 2, y is -1. And when x is 3, y is 0. We can continue to do this. And remember, all the formula for a function is just a way to generate these ordered pairs. Students often forget that. Now the range of f is the domain of f is 2, 3, 4, 5, and 6. So if I want to write down now the inverse of f, I know the domain of f is 2, 3, 4, 5, and 6, and actually the range of f is -1, 0, 1, 2, 3. So if I flip the order of these, I will get the inverse function. -1, 2 is the first point of the inverse function. 0, 3, 1, 4, 2, 5, and 3, 6. So I now have a set of points in f and a set of points in its inverse. And that's all I know about f. That's all the information I have been given. And we may need to just briefly review or think about the definition of the composition of a function. And remember, what that is I'm feeding g here into f. That's what the composition of a function is. Just a brief reminder before we move on. Next, let's consider the graph g of x. Now, in g of x, I can see, I know it's the x g of x graph because I can see the descriptor right here. So the points of g then, just like I did for f, the points of g are -1, 0, 0, 1, 2, 3, and 3, 4, and as you saw, as we did in f, it's now very simple to just simply write down the points of g inverse. So we have 0, -1, I'm just reversing the order, 1, 0, 3, 2, and 4, 3. And you may remember from the problem h of x was just 2 minus x. So I actually have all the information I need now to answer the questions. So I'm working on A, g inverse composed with f, an inverse of 0. So g inverse composed with f inverse of 0 is g inverse, and I'm going to feed in f inverse at 0. So I've got to look and see where that is, and I've got g inverse and my 0.03 from the f inverse there. Remember, f inverse at 0, this is the domain point here, and that's going to give me the range point of the inverse, which is 3. So this is 3, and now I've got to go over to g inverse and see what happens there, and I have g inverse evaluated at 3. Remember, this is now the domain point for g inverse, and that is 2. Next, we're going to do part B. And for this composition of functions, there's 3. And we have the inverse of h. We're going to feed in the inverse of g, and into the inverse of g is fed f of 3. So we've got to kind of really understand the nesting here. So the We're just going to carry the inverse of h and the inverse of g, and we're going to find f evaluated at 3, and f evaluated at 3 is 0. And the next thing we need to do is look at G inverse and find out what that is. So G inverse, the output of G inverse is -1. So now, well, wait a minute, we don't have a function for h at negative or h inverse. So what are we going to do here? Well, what we have to do is think this through. What value would provide -1 in h? So -1 equals 2 minus x. So if I add x to both sides and then I subtract, when x equals 3, I would get this result. So just for h at x equals 3, the result would be -1. So for h inverse then, of course, I just flip them, -1 and 3. And so I have to kind of do a little bit of thought here about the h value, and what I have here is 3. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.